Welcome back to Summarize Science, where we break down complex research for you. Today, we're looking at a fascinating discovery about superconductivity, a state where materials can conduct electricity with zero resistance. Superconductors are amazing, but most only work at incredibly cold temperatures, making them expensive and difficult to use. Researchers are always hunting for new materials that can superconduct at higher temperatures. This paper explores a material called bismuth, arranged in two ultra-thin layers, with one twisted on top of the other. This twisting creates interesting patterns and is part of a field called twistronics. While most studies focus on the perfect, repeating center of these materials, these scientists asked a different question: what happens at the messy, disordered edges? Think of it like this. The center of the material is like a perfectly stacked deck of cards, very orderly. But the edges, as their computer simulations showed, are more like a jumbled mess, with atoms in a disordered arrangement. This is shown here, where the core atoms are in a crystal-like structure, while the edge atoms are much more random. Normally, you'd think this messiness is a defect, a problem to be avoided. But the researchers found something incredible. This structural disorder at the edge dramatically changes the material's electronic properties. Specifically, it creates a massive spike in the number of available electronic states right where they're needed for superconductivity. You can see this huge difference in this graph, where the red line representing the edge is wildly different and much higher than the blue line for the core. This is the key ingredient for enhancing superconductivity. So, what did this do to the material's ability to superconduct? The results are stunning. The orderly core of the material became a superconductor at a very low temperature, around 4.6 Kelvin. But the messy, disordered edge became a superconductor at over 37 Kelvin. That's a massive, nearly tenfold increase in the critical temperature, all thanks to what was once considered a flaw. Even more interesting, this enhancement depends on the specific twist angle between the two bismuth layers. The researchers found that certain angles maximize this effect. So, let's recap the important points. First, the disordered, messy edges of a material aren't always a bad thing. Second, in twisted bismuth bilayers, this disorder creates a huge boost in its superconducting temperature. And third, this effect can be tuned by changing the twist angle between the material's layers. This new principle, called edge angle engineering, suggests that instead of trying to make materials perfect, we could intentionally design flawed or disordered structures to create better superconductors. It opens up a whole new avenue in the search for high-temperature superconductors, which could one day revolutionize everything from medicine to transportation. Thanks for watching Summarize Science.